Welcome to The Explainer. Today, we're diving into some fascinating new research that completely flips the script on how we cool data centers. We're going to show you how a hidden, often ignored cost actually makes sustainable cooling not just some environmental nice-to-have, but a massive financial win.
So get a load of this number, 5.2 trillion liters. That's the amount of water the world's data centers are projected to drink up every single year by 2031. It's a colossal figure, and it's putting the entire tech industry on a direct collision course with a very harsh reality, especially as these server farms keep popping up in the driest places on the planet.
Okay, so let's really get into this. To understand just how big of a problem this is, we're going to zero in on one city, Phoenix, Arizona. Now, Phoenix is a huge hub for those hyperscale data centers that power our cloud, our AI, but it's also a city that is under extreme, constant water stress.
Just think about it for a second. A single 100-megawatt facility, the kind of engine that drives modern AI, is in a head-to-head conflict with the very desert it's built in. The core problem? Heat. I mean, how on earth do you cool thousands of super powerful servers running 24/7 in one of the hottest places you can find? Well, that question brings us to the old-school solution and its massive hidden flaw.
For years and years, the industry standard has been these things called evaporative cooling towers. You can basically think of them as giant industrial-sized swamp coolers. But, and this is a huge but, in places like Phoenix, you've got these strict environmental rules that say you cannot dump the contaminated wastewater they produce. It's a policy called near zero liquid discharge, and it means every single drop of waste has to be collected and trucked away. That one rule changes the entire economic game.
And this, right here, this slide shows you the economic trap. Buying fresh water from the city, it's cheap, about $3 per cubic meter. But the real killer, the hidden cost, is getting rid of the waste. See, the process creates this toxic salty gunk called brine, and since you can't just dump it down the drain, you have to pay to have it hauled away. And the price for that? Over $66 per cubic meter. You're literally paying 20 times more to get rid of the water than you paid to buy it in the first place.
And that absolutely astronomical disposal fee leads directly to this number, $78.3 million. That's what it costs to operate a single, conventional 100-megawatt data center for 1 year in Phoenix. I mean, that's just not sustainable from a business perspective.
So the takeaway here is that the old model isn't just bad for the environment, it's financially broken. So what's the alternative? Well, let's move on to the innovation that completely changes the business case for the better.
The key to this whole revolution is an industry standard called ASHRAE W40. Now, to put it simply, it just means that new servers are designed to run hotter. They can use warm liquid. We're talking up to 40 degrees Celsius or 104 Fahrenheit as a coolant. Now, that might sound totally backward, but it's an absolute breakthrough. Why? Because if your coolant is already warm, you don't need giant power-guzzling air conditioners or chillers to cool it down. Instead, you can use these simple, super efficient dry coolers that work pretty much just like your car's radiator.
And we know this works because the data from Phoenix proves it. Just look at this chart. For 83% of the entire year, this warm water system can run completely dry. That means it uses zero water. It's only during those absolute peak summer hours, that other 17%, that it needs a little bit of help from a very light mist of water to boost its cooling power.
So making this huge shift from a cooling system that's mostly wet to one that's mostly dry has a really dramatic and really positive impact on the three things that every data center operator and investor cares about: water, energy, and of course, the return on that investment. First up, the water savings are just staggering. A conventional tower system guzzles over 800,000 cubic meters of water a year. To put that in perspective, that's enough to fill more than 320 Olympic-sized swimming pools. The new W40 dry cooler system, it sips less than 15,000. We're talking a 98% reduction, down to the equivalent of just 6 swimming pools. The difference is incredible.
And on top of that, the system is way more energy efficient. We measure this with something called PUE, or Power Usage Effectiveness. The easy way to think about it is a perfect score is 1.0. That would mean 100% of the power goes to the computers. Anything above that is basically wasted on things like cooling. So by getting rid of those power-hungry chillers, the PUE drops from a pretty inefficient 1.35 all the way down to a very sleek 1.12. That's a huge cut in wasted electricity.
And here, right here, is where it all comes together on the balance sheet.
When you slash those insane water disposal fees and you cut your energy bill, the total annual operating cost just plummets. It goes from over $78 million for the old way down to under $20 million for the new system. That's a savings of nearly $60 million every single year.
Which brings us to the number that every executive wants to see: payback. Now look, this new hardware does cost more upfront, but the operational savings are so massive, so profound, that you get a full return on that initial investment in just 1.5 years. After that, it's all gravy.
So, it's really important to understand this isn't just some theory or a cool idea. The research shows that this is an actual, actionable blueprint for building the next generation of data centers to make them both sustainable and incredibly profitable. So let's take a look at the road to get there. The research lays out a really clear 4-step plan. You start with the groundwork, validating the local climate data and getting all your permits in order. Then, phase 2 is putting in the core W40 hardware we've been talking about. Phase 3 gets even smarter by adding systems to recycle that little bit of water you do use. And then the ultimate goal, in phase 4, is to actually become water positive, to give more water back to the local environment than your facility consumes.
So, when you boil it all down, the takeaway from this research is crystal clear. Shifting to this kind of technology isn't just an environmental choice anymore. It's a strategic and financial must-do. The folks who wait are going to get stuck with crippling costs and endless regulatory headaches, but the ones who lead the way are going to secure their license to grow for years to come.
And really, this is the question that the research forces all of us to ask. It completely reframes the whole conversation. This stops being about just saving a few bucks here and there, and it becomes about essential, fundamental risk management for the future of our entire digital world.